Hey guys, what's up? Back here with day 8. Today I'm just going to do a quick recap of the 3 most important theorems that we have that we use throughout AP Calc. Something to remember here, theorems guarantee something to be true. When you're on the multiple choice section of the test, pay very close attention to a problem that sets up, and then they say, which of the following must be true? Usually when they ask that question, which of the following must be true? Usually, not always, but oftentimes they're talking about a theorem. Oftentimes when they say that, which of the following must be true? Several of the choices are things that could be true. Could be true and must be true are 2 different things. So have your antenna up whenever they say which of the following must be true. That takes usually a theorem to prove that to be true. Okay. Not always, but oftentimes. Okay, first theorem we learned was intermediate value theorem. The important thing to know for each of these theorems are what's required. To use the IVT, what's required is f must be continuous on closed interval. So, to use the IVT, f must be continuous on a b. What the IVT says, as long as the function is continuous, when we go from a to b, there are certain, right, those are x values. When we go from x equals a to x equals b, there are also corresponding y values for each of those, f of a and f of b. What that means is every number between f of a and f of b has to be hit somewhere between x values of a and b. So when we look at this, so we have some function that connects here and connects here. We just know it's continuous. I happen to draw one that's continuous but not differentiable. Okay. Well, what this is saying is that as long as this thing is connected, right? Here's a y value f of a, and here is a y value f of b. All of these y values along this line get hit somewhere along the function f of x. Okay? So f must be continuous on a, b. There must be a point c where c is between a and b, such that f of c equals, could equal any number between, this could be any number between f of a and f of b. Right? So for example, let's say a is 1 and b is 5. F of a is also is 2 and f of b is 10. Then for any number between 2 and 10, there must be a corresponding f of c value that equals that number, right? So it's guaranteed that there's an f of c that equals 3, or an f of c that equals 9, or an f of c that equals 5. Any number between 2 and 10, there must be a c value between a and b such that f of c equals that number. Okay? Now there could be an f of c equal to 11. There could be an f of c equal to 1. Those things could happen. but the only ones that are guaranteed are the numbers between 2 and 10. Okay? But again, IVT, in order to use it, you have to use continuity. When you're justifying, these are the things that you need to have in your justification. One, you must state continuity. Okay? You must state continuity. Sometimes it's just stating that they already told you it's continuous. You just have to state that in your justification. If they state differentiability, then state continuity, right? Since f is differentiable, f is continuous. Differentiability applies continuity. So you need to state continuity. You're either repeating what they said or implying what they said. So if they state differentiability, then you can say, since f is differentiable, f is continuous. Number 2, you must sandwich the number. So sandwich the number with your f of values. Right? For example, here I would say, right, f of a equals 2, f of b equals 7. Sorry, 10. Okay? You need to state your surrounding values. Then you state your conclusion with the IVT. Most of these things will be needed in your justification. Okay? Next, MVT. That is the mean value theorem of derivatives. What that's saying is that the instantaneous rate of change must equal the average rate of change on an interval, as long as the function is 2 things. F must be continuous on the closed interval AB, differentiable on the open interval AB. Okay? So I often say, right, to use the MVT, we have to have differentiability. Differentiability implies the continuity. Oftentimes what they go after, they love to ask you multiple choice questions that attack your knowledge that we need differentiability to use the MVT. This is the most important part right here. Okay? Average rate of change formula comes up in the mean value theorem formula. Okay? What this is saying is there must be a C on AB where f prime of C equals the average rate of change of f on that interval. The average rate of change is f of b minus f of a over b minus a. So that f of b minus f of a over b minus a isn't something new we have to learn. That's the average rate of change formula that we already know. Again, what this is saying in layman's terms, if I have something that's continuous on a closed interval and differentiable on an open interval, that means it has to not only be connected, but it has to be connected without any corners or anything like that. Okay? The average rate of change would be this slope. Right? F of b minus f of a over b minus a. That is the average rate of change is the slope that connects the two endpoints. F prime of c is saying that somewhere in here, maybe right here, there's an instantaneous, right? There's a tangent line whose slope is the same slope as the average rate of change. That's what the mean value theorem is saying, right? So sometimes they ask us through a table, right? Just do your average rate of change in your table. And we know that somewhere in between those two A and B values, there has to be a point somewhere where f prime of C equals f of B minus f of A over B minus A. And again, what's required is differentiability. That's the key. If they say there is no, f prime of C to equal f of B minus f of A over B minus A. If they say that, then the reason is probably because our function's not differentiable, right? All right, and the last one is extreme value theorem. Okay, so the extreme value theorem, f must be continuous. All three theorems require continuity, but the mean value theorem is the one that specifically requires differentiability in order to work. If we know something is differentiable, all three theorems can work. And all the EVT says is that absolute max, absolute min must occur on this interval, and they must be at endpoints or critical points. So if a function is continuous on a closed interval, it has to have an absolute maximum or an absolute minimum value. They must occur, can only occur at end points or critical points. Okay? So whenever they say, what's the maximum value of this function? Well, we don't have to check all infinitely many points. We only have to check the endpoints and check the critical points. If we check all of those, the biggest y value is our absolute max. If we check all of those, the smallest y value is our absolute min. Okay? You don't usually invoke the EVT on the test like you do the IVT and the MVT, but you use the EVT to solve for absolute maxes and absolute mins, like my video from yesterday or the day before. All right, that's it for our theorems for today. Keep going over those Quizlets. Do it every single day, right? Rather than looking at Instaface or whatever, run through those flashcards. Do it every day between now and the test day, and you'll be better. You'll score better, I promise. All right, talk to you guys later. 2 chains.